Particle sorting. So we can sort all these different particles and antiparticles into different categories. This is often called a particle classification as well. Here is quite a nice big chart of many of the different types of particles. It's worth studying this. You can if you Google fundamental particles and interactions or the standard model, you should be able to find this poster, which is really quite a nice summary of the different categories of particles. So how do we classify the particles? Well, the two main groups that we use are leptons, which is like the electron family, electron, muons, taus, antineutrinos and neutrinos. And the other side is the hadrons, and these consist of mesons and baryons. The hadrons aren't fundamental particles, and indeed the mesons and baryons are not fundamental particles. These ones are made out of quarks. Okay, but on the other side, the leptons, these are considered at the moment to be fundamental particles, i.e. we can't break them down any further. So what else distinguishes leptons from hadrons and so on? Well, it's also to do with the forces that they interact with. So leptons interact through the weak interaction and also through the electromagnetic interaction if they are charged. And then your hadrons interact through the strong interaction and if charged through the electromagnetic interaction. So leptons, they consist of electrons, muons, tau. There are also neutrinos to go with each of these, and their corresponding antineutrinos. And this all constitutes the lepton family. So as I said before, hadrons interact through the strong interaction, and these can be split again into baryons and mesons. Baryons are made from 3 quarks, and we'll look at quarks a little bit later, and mesons are made of 2 quarks. So what are examples of baryons? Well, baryons consist of, for example, things like proton, the neutron, and all other hadrons that decay into protons. Okay, so there are other hadrons that could decay into protons. On the other side, we have the mesons. These include things like your K meson, your pi meson, okay, and any other hadrons that don't decay into a proton. So to recap, baryons include things like protons and neutrons, that anything that decays into a proton. And on the other side, the mesons are things like your K meson, your pi meson, and anything that doesn't decay into a proton. So it does not. The decay products of these do not decay ultimately into a proton. And lastly, in this chapter on particle sorting is the idea of conservation of energy. We have looked at this before in some calculations, but when particles collide, you have their rest energy to consider as well as their kinetic energy. So if we've got a proton and an antiproton here colliding, we've got their rest energies because of their mass and their kinetic energies because they are moving, and that's before the collision. And then afterwards we've got the rest energy of the new particles plus any kinetic energy they have. So to work out the rest energy of the new particles, you need to have the total energy before the collision, which comes from over here, minus the kinetic energy of the new particles.